Hello, friends of chemistry. We're doing On Your Own 10.9 with Martin. And what page are we on, darling?
341.
341. All right. So please read 10.9 to me.
Barium hydroxide is often used to clean up toxic acid spills in industrial settings. If a 10.0 liter container of 12.0 molarity nitric acid, or HNO3, is broken and the acid spills all over the floor, how many grams of BaO2H2 will be needed to clean up the spill?
Well, it just says barium hydroxide. So
which is the equivalent.
Yeah, but we have to figure that out now for this video, right?
All right.
How many grams of barium hydroxide are formed? Okay, so the first thing to do is to figure out
how many is needed.
How many grams are needed? What is the barium? In the periodic table, it's in what column?
It's 2A.
Ba is the name or the symbol, and so it's a 2+. And hydroxide, of course, is one of our polyatomic ions. Oh, negative. So we need 2 of those with barium. So we're going to say BaOH2, right? So HNO3 and BaOH2 are going to react. Here's our acid, here's our base. And they're going to yield salt and a water. The salt is going to be Ba, and we know it's 2+. NO3 must be 1 negative, right? Because H is a plus. So we have to have NO3 2. There's going to be 2 of these, plus water, H2O. And there's going to be 2 of these, right? Okay. Write all that out.
I already have.
Great. Now, what does molarity mean?
It means moles over liters.
Number of moles per
number of liters. No, number of liters.
Right, but once we've got in this solid number, it's the number of moles per 1 liter.
Yeah.
Right?
Yeah.
So I'm going to use that information to figure out how many moles of, what is this again? Nitric acid? Of nitric acid I'm using. Because if I'm using 17, or let's say I'm using 10 moles of this, how many moles of this am I going to use?
Well, 10 moles?
It's 2 to 1. If I use 10 moles of this, how many moles of this do I use? Actually,
20.
5.
Oh,
5, because I use 2 to 1. If I use 2 of this, I use
1 of those.
1 of this. If I use 10 of this, I use
5 of them.
If I use 100 of these, I use
50.
Right. So we need to figure out how many moles of this we have. So molarity is moles per 1 liter. How many liters do we have?
10.
10. Okay, so 12.0, that's our molarity, is equal to 10.0 liters times, what am I doing here?
Actually, I think maybe it should look something more like this.
Times number Oh, the molarity, sorry. Okay, so 10.0 molarity for how many liters?
1. No, 2.
What am I talking about? It's 12.0 molarity, right?
Yeah.
Okay, so it's 12.0 molarity. And we have 10 liters. I'm losing it again. Okay, hold on. What we need to do is to look back here at this earlier stuff. We're talking about concentration. All right?
Yeah.
Okay. So how are we going to figure out how many moles we have from the information we have? Look, if this is right, then the number of moles, right, will be the molarity times the number of liters.
Yeah.
Okay? So, how many liters do we have?
10.
Okay, and we have 12 moles per liter. Right? That's the meaning of this.
Yeah.
Okay? There we are. So, this means this. So if we want to find out how many moles we have, we can do it with this number of liters. Liters cancels. How many moles do we have?
120.
Correct. 120 moles. Of what is this again? Of the nitric acid. Right? Okay. So, how many moles of barium hydroxide are we going to need?
240.
Are you sure? Look, if we need 2 of these, we need 1 of these.
Oh, it's
if we need
so
120
it's
of
60
these,
moles. So we need 60 moles of
we need
barium
60
hydroxide.
60 moles of barium hydroxide. Okay, that's not done yet. So we still need to figure out how many grams is that. But we know how to do that. How do we do that? Actually, it's not barium yeah, it is barium hydroxide. Yeah, sorry. I was looking all of a sudden at barium nitrate, but no, we're still barium hydroxide.
Find out.
Barium, what's its molecular weight?
Okay, so barium is 137.3.
Okay, oxygen is 16 and hydrogen is 1.01.
Yeah.
Add them up.
Remember, some of them are doubles.
Oh, thank you. Still not my answer. I'm just squaring it so we can see it. So we have 171.3 grams per 1 mole. Right? We could also say 1 mole per 171.3 grams. Right?
Yeah.
But we're going to use this conversion unit times the number of moles that we have. And how many moles do we have?
60.
And moles will cancel. And we have 171
times 60.
0.3 times 60.
10,278 grams.
Yes, let's look at our significant digits. This is perfect, so we should have 4. So 1.028 times 10 to the 1, 2, 3, 4, 4 grams. That's what I think. So that's how many grams we would need to clean up this spill.
Quite a spill. That appears to be correct.
Excellent. All right. Let us look.
At number 10.
Mm-hmm. Okay, now they said we had to be precise with our moles, and we weren't. So it should have been 1.03. This should have been 60.0
Seems to me we were
with
more
3
precise
significant digits.
than-
Excuse me. This
Oh.
one is 6. This is 100.
Oh,
So
we gotta use
here we had
digits,
3.
right.
Here we had 3. I should have 3. So this should really be 1.20 times 10 to the second moles. Make sense? Making this 60.0 moles. Right? I shouldn't say 120.0. That would be too many significant digits. I want to make this 0 significant though, as I want to have 3 here. So this should have 3, 60.0. This should be 60.0, so this should have 3 here. Okay, 1.03 times 10 to the 4th grams of barium hydroxide. Okay, so that's pretty complicated, right?
Yes.
All right. Now, acid-base titrations is the next part of the module. We've got to read that carefully. We'll be doing that in 10.10.